When I was in high school, I was in a band. No, not that kind of band. The kind of band with guitars and long hair and regret. As you can guess, we were pretty cool guys. We played about 4 total shows that actually paid us real money. And at one of those shows, there were 3 bands involved, and the amount that we got paid was based on admissions. Now, we made a whopping $100 on admissions, and that had to be split 3 ways. So, of course, in our naive state, we felt that that should mean that each band would get about $33.33. Well, one of the bands felt that they were more responsible for the amount of admission money that came in, that more people were there to watch them, and so they put up a bigger fight. And as you may guess, as high school students, we acquiesced, and they got a larger share of the money. This idea where a group that puts up a bigger fight can bring home a bigger share of the pot is a lot like the idea of voltage division in circuits. You see, in voltage division, if you have a set of resistors connected in series to a voltage source, the biggest resistor, the one that has the largest resistance, is the thing that's going to dissipate the most voltage. The idea of voltage division is really quite straightforward. When a set of resistors is connected to a voltage source in series, the resistors split up the voltage among them. Based on Kirchhoff's law, in fact, we know that the voltage on one side has to be completely dissipated around a loop. You can go and watch my video about Kirchhoff's laws for more information. The way to calculate the value of a voltage over any given resistor in a series connected circuit is to take the value of that resistance and divide it by the sum of all of those resistors that are in series, and then multiply that by the source voltage. In a way, voltage division is a really easy way to find the voltage at any point in a series connected circuit. In this quick example, we have a single voltage source with 3 resistors connected in series. Let's find the voltage across the middle resistor. This is found by selecting the resistor we care about, in this case, the 10 ohm resistor, and dividing that by the sum of the resistors, which is 3 plus 7 plus 10 ohms, which gives us 20 ohms. Taking that 10 divided by 20, we get 1/2. Finally, we multiply by the source voltage, which in this case is 12 volts, to get the voltage across the 10 ohm resistor to be equal to 6 volts. Similarly, we would find the voltage over the 3 ohm resistor to be 1.8 volts, and the voltage over the 7 ohm resistor to be 4.2 volts. As a last check, we can sum the voltages around the loop to see that minus 12 plus 4.2 plus 6 plus 1.8 equals 0, which jives with Kirchhoff's voltage law as expected. As you can see, it's really a lot like having a pot of money that has to be split up among bad garage bands. The group that puts up the biggest resistance takes home the biggest share. Thanks for taking the time to watch this video. I hope you learned something. I hope that it was educational and informative. If you feel like I've earned it, I would love it if you would subscribe. That's all for now. This is Dr. McPheron, signing off.